In today's video, we'll talk about Grignard reagents and borohydride reduction. They're pretty similar in that they are both nucleophilic additions, whereas here the nucleophile is the hydride, but in a Grignard reagent, the nucleophile is going to be the alkyl. Both of these have a second step of adding some sort of acid such as HCl. The purpose is to quench any unreacted Grignard reagent or sodium borohydride and to protonate the intermediate alkoxide. So this will attack the area of positive electron density. That will give you an intermediate epoxide, and this is the methyl from our Grignard reagent. Then this will attack the acid's hydrogen to become protonated, and that is the product. Whereas here, hydride would be the nucleophile. So important things to note is that this is a reducing agent. You could also use lithium aluminum hydride. This is a stronger reducing agent. It reduces everything, turns every carbonyl into alcohols, whereas using sodium borohydride only converts aldehydes and ketones into alcohols. So if you have a molecule that has an ester or carboxylic acid on one side and then ketone or aldehyde on the other side, and you use this, then you would selectively reduce it into alcohol. Okay, so during the preparation of Grignard reagents, how to prepare Grignard reagent? So you get some sort of alkyl halide. You react it in Mg and diethyl ether. So during preparation of Grignard reagents, there is a main impurity, which is called the alkyl dimer. And yeah. So other important things to note is that you have some side products. So if we were using Grignard reagent, we would have an HCl gas, which is why we need to use a gas trap to prevent the fumes, as well as an MgBr with a chloride. Whereas if you used the reduction reaction, your product will include some salt, NaCl, as well as a BH3. So the Na reacts with Cl, and this loses a hydrogen, as can be found by inspection. So other important notes is that in Grignard reactions, we have to flame dry all the glass so that the Grignard reagents don't decompose under moisture. Okay, so we flame dry everything for Grignard reactions so that the Grignard reagent does not decompose. And to prevent moisture from getting into the reactions, we place a calcium chloride drying tube on the top of the addition funnel. Okay, so we put a drying tube so that our Grignard reagent doesn't decompose under moisture.